This is section 1.3, solving equations. First, example 1, write an algebraic expression that represents each verbal expression. Example A, 2 more than 4 times the cube of a number. Anytime you have the word more than or less than, that means you put that in the back. So you kind of flip-flop the order. So you would write 4 times the cube of a number first. And 4 times the cube of a number is 4x cubed, and that goes in front. And then the 2 more than means we're going to add 2 to the 4 times the cube of a number. Example B, the quotient of 5 less than a number and 12. Quotient means to divide. So what you read first after the quotient goes in the numerator. What you read after the word and goes in the denominator. 5 less than a number. Remember what I just said about more than and less than, that if it has the word more than or less than, you flip-flop the order. So 5 less than a number, that means the number x minus 5. And that would be divided by 12. Example C, the cube of a number increased by 4 times the same number. Cube of a number is x cubed. Increased means to plus. 4 times the same number, that means to use the same variable, 4x. Example D, 3 times the difference of a number and 8. The difference of a number and 8 means subtract. So x minus 8, and then we have to multiply 3 times all of that stuff. So we have to put all of that stuff in parentheses. Example 2, we're going to write an algebraic equation. The product means to multiply. The product of 6 and a number is 72. So that's 6x equals 72. Example B, the sum of a number and 15 is 91. Sum means to add. So the sum of a number and 15 would be x plus 15 is 91 equals 91. Example C, twice a number is the same number squared minus 4. Twice a number, so 2 times x, is the same, that means equals, the number squared minus 4. Example 4, we're going to solve and check. To solve for n, we're going to do what's ever the opposite. So we're subtracting 3.24, so we're going to add 3.24 on both sides. Now remember, when you're adding or subtracting decimals, you line up the decimals. To check, I call this a T-bar check, where I write the original problem, put a line down to separate where the equal sign is, and plug in what n equals. And when you plug it in, your left side should equal your right side. Okay, example B. Anytime you have a fraction times a variable, we want to get rid of that fraction. To get rid of the fraction, we multiply both sides by the reciprocal. So the reciprocal of negative 5/8 is negative 8/5. So we're going to multiply both sides by negative 8/5. That 20, we have to turn that into a fraction by putting it over 1. Cross reduce, the left side, the 5's go away, and the negatives go away, and the 8's go away. So we just get x. On the right side, we're going to cross reduce. 5 goes into 5 one time, 5 goes into 24 times. So then we multiply and get negative 32. Technically, that's negative 32 over 1, but when you have a 1 in the denominator, you don't have to write it. To check it, write the original problem, plugging in negative 32 wherever you see x. Simplify using the order of operations, the left side. I'm going to cross reduce and get 20, and the right side is 20, so it checks. Now you try to do example C. Turn off the video, you try to solve it, and then turn it back on and see if your work looks like my work. In example 5, the first thing we're going to have to do is the distributive property. So we have to multiply 5 times everything in that parentheses, and then we multiply 2 times everything in the second parentheses. Now before we start moving from one side of the equal sign to the other, we're going to combine like terms. Always remember that you have to combine like terms on each side of the equal sign. I call that my cleanup phase. So I am going to combine the 5x and the 2x, or excuse me, the negative 2x, and get 3x. Then I'm going to combine the 15 and the 2 and get 17. Now I am ready to start moving things from one side of the equal sign to get x by itself. So I'm going to subtract 17 on both sides. And I get 3x equals negative 3. Then I'm going to divide both sides by 3. And I get x equals negative 1. To check it, I'm going to write the original problem. And wherever I see x, I'm going to plug in negative 1. Then you want to simplify using the order of operations. Order of operations says to do the parentheses first. Inside the parentheses, I'm going to combine negative 1 plus 3 and get 2. And the second parentheses, that 1 minus a negative 1, that changes to 1 plus a positive 1, which turns into 2. Then I'm going to multiply and add, and I get 14 equals 14, so it checks. Now you try to do example 5b on your own by turning off the video, then work it, turn the video back on, and see if your work looks like mine. Let's try one more. Try this problem, then turn it on and see if your work looks like my work. But be very careful about those negatives. When you're distributing a negative in the parentheses, you have to carry over that negative. That's where a lot of people make their mistake. Example 6. The area of a trapezoid is A equals 1/2 times h times base 1 plus base 2. And we're going to solve for b sub 2. Now this is a little bit more complicated when you have more than one variable. Your goal is to get b sub 2 by itself. Well, first we've got to get rid of that 1/2 and we've got to get rid of the h to get inside that parentheses. We're going to multiply both sides by 2 because our goal is to get rid of that 1/2. So to get rid of the 1/2, we're going to multiply by the reciprocal. So I'm going to multiply both sides by 2 over 1, which is the same thing as 2. Then we're going to get rid of the h. We're multiplying h times that whole parenthesis. So to get rid of it, we're going to divide by h. And then you just get the parentheses, and you don't have to enclose it in parentheses anymore. Our goal is to get b2 by itself, so we have to get rid of the b1. We're adding the b1, so to get rid of it, we're going to subtract. You're going to use little equations a lot in physics, and I've gotten a worksheet from your physics teacher, and I've done a couple problems on this video, so keep watching the video. There's multiple problems of literal equations. We're going to solve for h. So the very first thing we're going to have to do is get rid of the very first term. We're adding the first term, so we're going to subtract it. Okay, our goal is to so we're going to divide by 2 pi r on both sides. Here's number 39 done for you, so you can check to make sure you're doing it correctly. And here's number 41. Now, on number 41, you're multiplying 2/3 times each term in the parentheses. If you need to go to the side and multiply 2/3 times 6, then you cross reduce and you'll get 4, and there's a C, so it's 4C. Then I'm going to go to the side and multiply 2/3 times 18, cross reduce, and I get a negative 12. Now you try it on the other one. Okay, here's some more literal equations. The very first one, we want to solve for f. F is in the denominator, so we've got to get in the numerator. To do that, we're going to multiply each term by the least common denominator. The least common denominator is every single letter that's in the denominator. So the letter is F, D sub 1, and D sub O. So I'm going to multiply each term by all three of those letters. Then I'm going to cross reduce. The very first one, the F's go away. The first term on the right side of the equal sign, the D sub 1's go away. And the second term, the D sub O's go away. Now, if you notice, there's an F in is the common term in the second on the right side of the equal sign. So I'm going to factor out an F. And my goal is to get F by itself, so I have to divide both sides by that whole parentheses. So here's a couple more for y'all to try. And that is the end of section 1.3.